circles. Some say they don't exist, some people say you've never seen them, but regardless, you can use circles to help you demonstrate the relationships between logical premises and actually figure out the validity of arguments. So first of all, let's look at a map of the main regions, and there are 6 main regions of any Venn diagram. And Venn diagrams are going to be what we use to represent our arguments. So right here in the middle, right, marked by the number 3, you get the place where all 3 of these circles intersect. All right, then surrounding that, put 2, 4, and 6 over here. 2, 4, and 6 represent places where 2 of the circles overlap, but not all 3. And then finally, 1, 5. And what's the other one? What am I missing? I'm missing 7, aren't I? Yep, there we go. Okay. And then 1, 5, and 7 represent the areas where there is no overlap whatsoever. Now, when we're trying to represent terms, we have to do 2 things. We have to either shade or we have to put an X. So think back to our 4 main logical statements, right? We have all, we have no, we have some, and we have some are not. Now, with these 4 kinds of statements, we have 4 different areas we have to either shade or put an X next to. Now, you shade an area that is empty, and that means that there is no part of that area that is representative of either of the terms. So if I were to say all A is B, right, there would be no part of A that is not B. So I would shade this part right here. Happy little shading right there, right? And then down here, if I said no part of A is a part of B, where do you think I should put it? Right here in the middle. Just shade and shade and shade till, yep, there is nothing that is both A and B, right? No part of A is also a part of B. Now here, when we get to our sum statements, we run into a little bit of difficulty because we have to use an X. And what that means is that X represents there is at least 1. There is at least 1 of whatever class in the area, right? So if I say sum A is B, that means that there is some part of A, there is at least 1 of A that is also in B. So I would put an X right here in the middle. There is at least 1 that is both. But if I come down here and look at sum A is not B, where do I put an X? Well, I put it right here. There is at least 1 part of A, 1 member of class A, that is not a part of class B. So there you have it, shading and X's. Given that we now know how to represent these statements, let's test it out in an argument. So let's use one of my favorite arguments, the argument that a burrito is perfect. So if I said that all burritos are perfect, and then I said no taco is perfect, and then I conclude no burrito is a taco, right? I have an argument that I need to figure out whether or not it's valid. So how do I do that? Well, the first step with Venn diagrams is you got to draw your circles. And each circle represents one of the terms. So then you go and you figure out what are the terms. Well, burrito is a term, so that's marked with a B, and perfect is a term, so that's marked with a P, and taco is a term, so that's marked with a T. Now, I have to go through my premises and represent those relationships. So all burritos are a part of section P, right? So that means that I shade in all parts of the B circle that are not a part of P. It's a lot of shading. So we're going to be here for a while. Right? There we go. Then I look at my second premise. No taco is perfect. That means there is no part of T that touches P, right? So I shade that area as well. And do that real quick like that. Smudge that so that, you know, I'm like blocked by the circles. Smudge that so that you can see it. But now we've represented our premises. So on the basis of this representation of our premises, what can we say? Well, can we affirm the conclusion, right? Can we affirm that no burrito is a taco? Well, that would mean that there's no part of B that also touches T. And if that was the case, then this whole area where they overlap would have to be shaded in. And lucky for us it is, which means that this argument is valid. It's also true. But what happens if we use an invalid argument? Now, we'll use the same example as before, except I'll switch it so that I know that it's invalid. You know it's invalid, but, you know, we're just going to pretend that we don't know. So I changed it to say no burrito is perfect, which makes it invalid for reasons that you'll know right off the bat, like next week or so. Anyway, we go through our steps. We draw our three circles. We label them burrito, perfect, and taco. And then what do? We shade. So no burrito is perfect. That means that I color in this area right here, like that. And then no taco is perfect, so I color in this area as well. And can I conclude then that no burrito is a taco? No, I can't conclude that because of this area right here. That area right there, in fact, would make me conclude that, yeah, at least some burritos are tacos, which, you know, isn't true. But also shows that this conclusion does not necessarily follow from these two premises. In other words, it's invalid. All right, so for the sake of being thorough, we're going to do an example that requires us to use an X. So let's try this argument. No dogs are furry. Let's see. Oh, sorry. Can you go back? Yeah. Okay, that's good. All right. So let's try this argument. No dog is furry. Some horses are furry. Therefore, some horses are not dogs. Profound, I know. Now, what do? Well, we draw our circles. We figure out what our terms are. And we represent those terms. D, F, and H over here. And then we shade and or use an X. So first of all, no dogs are furry. Well, I shade this area in right here, like that. And then some horses are furry. That means at least one horse is a furry horse, which, is entirely possible. And on the basis of that, can I conclude that some horses are not dogs? Well, maybe. There would have to be an X in the horse circle in order for there to be, in order for this to be correct. And there is an X in the horse circle. Granted, it's also in the place where it overlaps with furry. But it is in the circle, which means that there are some horses that are not dogs. So I guess it's valid? I don't know. Maybe. It's probably valid. We'll say it's valid.